Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra II class. Today we're going to wrap up matrices, and we're going to talk about something pretty awesome called Cramer's rule. Now, when you first see it, it's going to look daunting. It's going to look very intimidating. You're going to be thinking to yourself, what is this witchcraft that Mr. Morrow is trying to throw upon us? It's pretty simple, actually. For systems of linear equations, we can use matrices. Now, some of you may say, yeah, but we can also graph it. We can use substitution. We can use elimination. So who cares? Well, you're right, and you're right. However, when you get really good at figuring out determinants, you're going to find that this is much easier. You don't have to go through the complications of elimination or substitution or graphing. So I really think it's important for you to know Cramer's rule. Plus, you're going to get quizzed and tested on it. So without any further ado, let's get to this. Remember that the solution of a system of equations with two variables, we're looking for a value, a point where both lines intersect, okay? And that solution has to work for both equations. So what's going on here? When I have this system, my x value will equal the determinant of x over the main determinant of the original system. My y value will equal the determinant of y over the main determinant of the main system. Now, what are you talking about, Mr. Morrow? Okay, the main determinant here, we're going to just call that straight up D, is literally the coefficients of the first equation, that's my A and B, and then the coefficients of my second equation, which is my C and D. Good news, if that equals 0, you can stop. There's no solution here. You cannot use Cramer's rule here, okay, if the determinant is 0. All right? Now, how did I get my D of x and D of y? Some of you may think Mr. Morrow made a mistake here, but I didn't. Notice that there's a common thread in D of x and D of y. It's EF. If you notice what happens here, guys, I take my EF value and I replace them with my A and C. So hence I have EF and then BD for these two guys. That's how I find my x. So basically, when I'm finding my x, I'm replacing my E and F with the coefficients of x. To find my determinant of y, check out what's happening. I'm taking my EF, and this time I'm replacing it with my coefficients of y. So I'd have the coefficients of x and then EF, and that's my determinant of y. So determinant of x, I replace my EF with my coefficients of x, and I keep the coefficients of y. To find dy, determinant of y, I keep my coefficients of x, and I replace the coefficients of y with EF. That's what's happening here, okay? Now, a lot easier when we actually do a problem. So straight up, let's first find the determinant D of the system. Remember that this is my A, B, C, D, E, and F, okay? So my main determinant will always be A, B, C, and D. So my main determinant here, my matrix is 5, 7, 2, negative 5. My determinant here will be negative 25 minus 14, which equals negative 39. So guess what? I already have the denominator. I already have the D. Gotta admit, that's not too bad, right? Okay. Now I have to find, though, my dx and my dy. Okay? My dx and my dy. So let's find my dx and dy. my determinant for my x values, I'm going to replace the E and the F with A and C. So I'm going to have 13 and 13 in this case, and then I'm going to have 7 and negative 5. Again, what did this crazy man do? I replaced my E and F with my coefficient of x, and I left the y's. Does that make sense, my brothers? So let's find this determinant, gentlemen. This is negative 65 minus 91. Is that correct? I believe so. And then that's going to give me negative 156. 256? No. 156. The signs are the same. Let me just, now I'm questioning myself. Yes, 156. So that's my d of x that I did in green. You feel me? Everyone with me, my brothers. Now would be the time to ask, my brothers. Now would be the time to ask. Okay. Now let's find dy. Now this time I'm going to remain with my x and my x coefficients, and I'm going to replace my EF with my y coefficients. So what I'm doing now is I'm replacing my EF where the coefficients of y went, and I'm leaving my x coefficients. So this d of y matrix will be 5, 2, 13, 13. And that's going to equal 5 times 13 is 65 minus 26. And I believe that's 39. Go ahead, my brother. Thank you. Remember, for the d of x, I replace my EF with the coefficients of x. And then for dy, I replace my EF with my coefficients of y. Thank you, my brother. So now I have everything I need, guys. So let's find the solutions. So my x equals my d of x, which is negative 156 over negative 39, which I believe is 4. Yep. So x equals 4. No, it's, I don't know why you would say 13, because my original determinant was negative 39. And for whoever said it would be negative, a negative divided by a negative is a positive. But thank you guys for caring. And then y would equal 39, which is my d of y, over my main determinant of negative 39. So y equals negative 1. So my solution is 4, negative 1. Now, I don't believe you. I want to test this, Mr. Morrow. Fine, let's test it. 4 and negative 1. 5 times 4 is 20. 20 minus 7 is 13. It works. Let's just clean that up a little bit. And then 2 times 4 is 8. And 8 plus 5 is 13. So it works and it works. It's not that bad, is it? Not that bad at all. If you know determinants. If you don't know how to do determinants, oh my God, this is a nightmare. Yeah, you're absolutely right, guys. You want to cry. Okay? So that makes sense, my brothers. Okay. May I continue? I see some people writing still. Yes, sir, my brother? Need me to pause real quick? You got it. Okay, thank you. So now, yeah, we'll do a couple practice ones, and then I'll show you the 3x3s. Okay, so let's knock this out. First things first, let's find my main system matrix, which is 1, 2, negative 1, and negative 8. Sorry, negative 2 here. Sorry, thank you. So let's find my main determinant. 1 times negative 8 is negative 8 minus negative 4. So my main determinant is negative 4. Everyone with me there? Okay. Now, let's find my determinant of x here, okay? To find my determinant of x, I'm going to replace the e and the f with the coefficients of x. So I'm going to have 0, -9, 2, -8. Determinant of this bad boy, 0 times -8 is 0, minus -9 times 2 is -18. So that would equal 18. It's my d of x. Okay? And then, last but not least, my d of y, I replace my e and f with the coefficients of y. So I've got 1, -2, and then I've got 0 and -9. Everyone with me here so far? Promise? Okay, so this is -9 minus 0. So that's -9. Now, are the answers going to be pretty here? No. That's just sometimes the way life goes, unfortunately. So my x will equal my d of x, which is 18, over -4. So let's go ahead and just call that -9 halves. Right, guys? Or, if it makes you happier, -4.5. Okay. And then let's find my y, which equals -9 over -4, which is 9/4, or 2.5. Does that make sense, guys? Does that make sense? Okay. Okay, guys, I almost went crazy here. Mr. Morrow needs to learn how to do math. 9/4 is not 2.5, it's 2.25. So my solution is -4.5 or -9 halves, comma, 2.25. And when you do plug it in, it does work, okay? Now there's one more here. I ask you guys to do it. Just follow the procedures, because I got to teach you the 3x3s and we're running out of time. Okay, now. I'm laughing because I know it looks intimidating, okay? It's not that bad, I promise. It's kind of the same thing, guys. The x is the dx over d, y is dy over d, and the z is dz over d. The main determinant comes from the coefficients of these guys. So this down here is the main determinant. Okay, that's pretty simple. Now, remember how in the 2x2s I replaced my e and f with x when I wanted to solve for x, and I replaced the ef with y when I wanted to solve for y? Same exact thing here, except check out what I'm doing. For d of x, guys, I'm replacing the j, k, and l with the coefficients of x. See? See that? And then I'm leaving the coefficients of y and z. To find my d of y, I'm replacing my j, k, and l with the coefficients of y. And I'm leaving the coefficients of x and z. And last but not least, to find my d of z, I'm replacing my j, k, and l, this time in green, with the coefficients of z. So this is still simple. I'm going to be honest, I think this is easier than solving by substitution or elimination a 3-variable system, because you guys remember the test on that and you guys did not enjoy that. So this is easier. It's just a matter of, yeah, you have to find 4 different determinants. Yes, it's a pain in that sense. I give you that. But other than that, it's not that bad. So let's run through one at least. Okay? Okay, number 1, always find the main determinant. So to find my main determinant, I'm going to use my main matrix, which is 3, -6, 9, 1, 5, -2, 1, 3, -1. Good job. Then I'm going to go ahead and bring over the first 2 columns, right? 3, -6, 9, 1, 5, and 2. Please be neat. Okay, so starting here, I've got negative 15 plus 27 plus negative 12. And that sum is 0. So that's 0, correct? Minus, okay. Now I've got 9 times 5 is 45 plus 3 times negative 18 plus, that was a negative 1, right? Yeah, negative 1, so that's plus 6. So that's 51 minus 18. What's that? That's 33, correct? Yeah. Yep. So my determinant, my big D, is negative 33. Okay, we know that. You with me here, guys? So far? You with me? Promise? Okay, let me go ahead and copy this. Actually, let me clone it so I can work with it down here. Okay, so now we got to find the dx, the dy, and the dz. Okay, so let's first find my dx. My dx, I'm going to replace my jk and l, or jlk, with my coefficients of x. So instead of the 3, negative 6, and 9, I'm going to have negative 1, negative 9, 5. Then I keep the coefficients of y and z. And if you notice there's a typo here, that should be a z. This is a 1, 5, negative 2. And then I have a 1, 3, negative 1. Then I bring over the negative 1, 1, the negative 9, 5, and the 5, negative 2. Okay, so negative 1 times 5 times negative 1 is positive 5, plus 1 times 3 times 5 is 15, plus positive 18. So that's 20, that's 38. So 38 minus, now I have 25, that's negative, plus 6, and that's 9. So that's 40? Yep, 40. So this equals negative 2. So d of x equals negative 2. Are you guys with me here? I know this is not as fun as going out and having a good time, but it's not that bad, is it? Now to find my dy. My dy, I'm simply going to replace my jlk. Remember? My jlk, or jkl rather, sorry, with the coefficients of y. So now I'm going to have 3, negative 6, 9. Instead of the coefficients of y, I'm going to replace it with negative 1, negative 9, 5. Keep the z coefficients, 1, 3, negative 1. Now put the first two columns here to make our lives a lot easier. Okay, so I've got 27 minus 27 minus 30. So that gives me a negative 30. And then I've got negative 81 plus, that's 15 and 3, 45, plus negative 6. Okay? So I've got negative 87 plus 45. Yeah, negative 81 and negative 6, negative 87 plus 45. That's negative 32. So minus a negative 42. So my dy is 12. You guys with me here? So my dx is negative 2. My dy is 12. I just need extra space, so I'm going to erase. Now let's find my d of z. My d of z, now I'm going to replace my coefficients of z with JKL. So I have 3, negative 6, 9, 1, 5, negative 2, negative 1, negative 9, 5 instead of the coefficients of z. Then I have 3, negative 6, 9, 1, 5, negative 2. And let's rock and roll. This is a 75 minus 81, and that's minus 12. So negative 81 minus 12 plus 75 is equal to negative 18. Okay, minus, this is negative 45 plus, that's positive 18 times 3 is 54. And then that's negative 30 minus 30. So that's negative 75 plus 54, which I multiplied. Negative 75 plus 54, which is a negative 21. So negative 18 plus 21 would be 3. So d of z is 3. My original main determinant was negative 33. Okay, so I have x equals negative 2/33. Is it negative 33 or 33? Okay, so x equals 2/33. Y equals negative 12/33. And z equals negative 1/11. Okay, boys, surprise, surprise. Mr. Morrow made a mistake, a very grave error. This 2 here should be a negative 2. Maybe I should learn how to pay attention. That's why I tell you guys to pay attention, because I want you to be better than me. That should be a negative 2. So the good thing is that everything is fine here except for this sum right here. That would have been a positive 12. See that? See that, guys? So what happens here is, this is yeah, this is, no, not 20. Well, negative 15 plus 12 is 3. And then 3 plus 27 is negative 3. So it's 24. Okay, very good. So instead of being a 0 here, this should be a 24. And then what's 24 minus 33? 24 minus 33 should be negative 9. Okay, so everything here stays the same except should be over negative 9, Mr. Moro. So this would be negative 2 over negative 9, we said. So x is 2/9. And y would be 12/9, which is, take away a 3, 4/3. Negative, thank you. And z would be negative 1/3. Okay. Now that makes more sense. Okay? So sorry about that. Don't be a Moro. Pay attention. Thank you very much, guys. I hope you learned a lot. Have a great day. Bye-bye.